Yay, indeed. I've done it. I've done it. We've done it. Between us, we've managed to get over 50 followers. Thank you so much. And this has now become a tradition on this channel when we achieve something. Let me just find the track. Where's it gone? Oh, I've got the wrong account on YouTube at the moment. Where are we? Switch to me. Audio library. Sort by title. Mustn't do that again. I've got a cramp in my leg doing that. Enough of that. Ow, cramp. Oh, too much activity for me, that is. Oh, there. It's gone. Ah. Ah. Right. Okay. What I have is my old Amiga 500 motherboard, for which I designed a few extra circuit boards for a while ago. However, shortly after designing them, I had an issue with my computer where one of the system processes decided I didn't exist anymore, and since I didn't exist anymore, my home directory didn't need to exist anymore, so it just deleted it, which was very, very helpful, and I hadn't got around to backing up those files just yet, so I lost them all. So I want to redesign those circuit boards and design some more and make the ones that I did before even better. So the two main ones that I had designed are the power input board and the ROM switcher board. Kickstart switcher board that I'd made. Both pretty simple, straightforward boards. Yeah, my backups were happening nightly, and it happened between sort of sending off or finishing the designs and sending them off, and that night. So yeah, I was kind of gutted, but it's not too complicated a board to recreate, so I wasn't that worried about it. I'd already sent off the designs, so right. Let's get some extra light on here and see if I can get this viewing. That is the power supply board that I designed, and I had to be at the time quite cunning with it, because one of the chips I could not find a surface mount version of, so I had to use a through-hole one, but I needed it surface mount because the whole board goes flush with the main motherboard. So I mounted the chip rather dusty, this board, raised up with some spacers so that it doesn't poke all the way through the board. But I really, really want to find a fully surface mount equivalent to that chip, if I can, in the new design. And in the ROM switcher board, it wasn't a ROM switcher board originally, it was just a replacement kickstart. But I manually added bodge wires and a switch to allow me to switch with a larger ROM on there. So I'd like to redesign that with that switching built in. So, yeah, I'm not sure where my hat is offhand, actually. I don't really wear it if I'm not working on electronics or whatever, because I wear it mainly to keep my hair out of my eyes. But I don't really need it today because I'm going to be working on the screen all the time. So those are the two main boards that I had designed. There is another one which I've created but never actually got around to using. And that's this little board, which had a 9-pin connector on one side, PS2 connector on the other side, and a little 8-bit microcontroller in between. You can send me your modem if you like, I'll have a look at it, yeah, by all means. Make a stream out of it. And the idea with this board is it goes into the mouse connector and lets you plug in a PS2 mouse, basically. I don't really need to make any changes to this one, but I would like to recreate it at some point anyway to, and then create the actual circuitry for the firmware and build one up and try it out at some point, but that one's a lower priority. But coupled with that, I've also got this monstrosity, which is an ESP32 development board with some PS2 connectors and a bunch of cables, basically. The actual physical manufacturing I have done in China because it's just so cheap and easy. In fact, I've got a little batch of boards here that I've had delivered a couple of days ago that I got to build up at some point. I can make my own boards here, but just not to the sort of standard that you can have made in China. But yeah, this board is set up as to do the same thing that this one does, plus also PS2 keyboard interface. So this cable here would plug into where the keyboard plugs into. So I'd like to design another small board that does this job for both the mouse and the keyboard on one circuit board, basically. But I don't want to use the ESP32. I have a rule with this Amiga. Any sort of enhancements that I do on it, and I want to do a lot of enhancements on it, I've got all sorts of plans for this. But any enhancements that I do on it, I must not, and I will not, use any processors or microcontrollers that are more powerful than the Amiga itself. And the ESP32 is far more powerful than the little 16-bit Motorola 68,000 on the Amiga, so I really don't want to use that. So I'd like to replace that with an 8-bit microcontroller instead. So that's the fourth board that I want to design. No, I don't think so. But for future board designs, I also want, and I actually prototyped this up at one point, and it's all spaghettified now. Wear a bit to the tar now, but that's part of it. That's part of it. There was a breadboard with loads of spaghetti wires and all sorts on it. But it's a memory expansion and compact flash or hard drive, IDE hard drive interface as well, which I really want to get around to properly designing at some point as well. So, but that's for the future. For now, I just want to redesign these boards. Let's have a quick scroll. Have I missed anything important in chat? I don't think I have. Yes, you can keep the Dells, thanks, Carrot House. I do not want Dells. I've got a Dell. It's my main workstation, and I barely tolerate it. Right. So we'll start with the interesting one, which is the power interface. If I switch over to my other computer, this is an image of an unmodified Amiga 500 board, same revision, 6A. And the power input on it is a great big chunky square connector that has all the voltages coming in and a choke, basically, for noise suppression. So the board that I designed replaces both the power input and the choke and fits nice and snugly in this area where the connector and everything goes. I've actually got a blank board here. You can better see the shape that I had to come up with for it. There we go. That nice strange shaped board fits absolutely perfectly snugly in the space of the connector and choke. So what this board does is it takes in just 12 volts. Thank you very much, CopHC. I couldn't have done it without you guys. You really did help to spread the word and get the followers. So now I'm just waiting for my email from Twitch to say, you can become an affiliate now. Would you like to? At which point I say yes, and we get bits and cheers and emotes and all sorts of fun things to play with. So yes, this board, it takes in, let's switch back to the desk view. It takes in 12 volts through a standard barrel jack and converts it out into 5 volts, passes the 12 volts through and also creates minus 12 volts. So it's basically pass the 12 through, step down to 5 volts and invert into minus 12 volts. Now the minus 12 volts is only used by the audio circuitry, and that's only line level, very low powered stuff. So it's very tiny current needed on the minus 12 volts. So I actually chose a charge pump inverter because it uses very few components. There's basically two ways of doing inverting of a voltage. You can either use a switching power supply, basically, which instead of referencing to ground, references to your input voltage and turns itself. It's basically upside down and gives the power out backwards. That takes coils and diodes and all sorts of things. So, well, that's the point. Mock Helix. I don't have the schematic anymore. That's what I'm doing today. I'm going to be recreating this schematic, and then I can redesign the board, and then I can hopefully have a better design of the board as well while I'm at it. So, but the other way of inverting a voltage is basically to charge up a capacitor, disconnect that capacitor, turn it around, and then connect it to the output. And then you do that really fast, and you're creating a negative voltage. And that's how this specific chip works. It's a charge pump. It charges it up, charges up a capacitor, and then it pumps it out into the rest of the circuitry backwards. So I'd like to find an equivalent charge pump inverter chip that does enough current to power the circuitry. When I first created this board, I actually did a few tests to see how much current was being drawn, and this was the only chip I could find that would provide enough current, and I can't even remember what this chip is offhand. So I'm just gonna have a look, see what the chip is. It's a microchip one because I like microchip. If I can focus. This is the TC7662A. TC7662A. Let me just bring that up. Go right. TC7662A, which can provide 40 milliamps of output. So I'd like to try and find a properly surface mount chip that is a charge pump inverter that can do at least 40 milliamps. So DC to DC. Oh, no, it's. Where are we? I want charge pump ICs. Parametrics. Let's see if they've got one yet that will give a I want V out equals minus V in or 2 V in. So this is for chips that will either invert the incoming voltage or double the incoming voltage. I think they might even have discontinued this chip. Which one was it? It was the... Oh, thank you so much, Microchip. Thank you. Just as I'm starting work. Okay. Actually use a different system. I'm going to cheat now. A repository of schematics. You mean for existing devices? It's poking around, basically. There isn't really a repository. we're going to do. TI Web Bench. Fantastic system this is. Texas Instruments Web Bench. I want to create a new power supply design, which will give me 12 volts in, minus 12 volts out at 40 milliamps. Small footprint, a few designs, and my job is done. See what it comes up with. If it can. An automated power supply design tool. It makes my life so much easier. But I bet they're all... Oh, actually, I was going to say, I'll bet they're all switching inductor based, but no, not necessarily. Or if they are, it's integrated. And I like integrated. No, there's no charge pump designs here. But if there's an integrated one, then that's a possibility instead. This is the LMZM 23601. That's a SIL module, a couple of resistors, a couple of capacitors, and a diode. That looks an interesting design. That might be doable. It even does the PCB layout for you. I've never tried generate Gerber files from ChatGPT. It's even better than a surface mount chip. I can show you what it is because I'm already using something very similar in my design. It's called a SIL. S-I-L. If I switch back to the microscope. That there, it looks like an inductor, a surface mount inductor, but it's actually mounted on another little circuit board underneath it. That is the 5-volt switching regulator that can provide 3 amps of power. And it is microscopic. In fact, I can possibly find an unused one in my box here somewhere. Might have a similar one here. To change my glasses for the close-up one. I'm sure I've got something somewhere. There we go. And let's get the microscope back. that's what they are. Tiny little circuit board with the chip embedded inside it, and the inductor for the switching power supply built into the top of it. They're ingenious tiny little devices. Can I put a coin next to it? Not in the same shot, I don't think. What have I got for scale? I haven't got a banana to hand. I've got here's a pound coin. Scale. And I shall have to zoom out. There we go. They are somewhat tiny. They don't have a bottle cap to hand, I don't think. No, I tend to open my bottles downstairs and pour them into a glass. But yeah, they are microscopic little things. Got that other one. And yeah, no. Thought I had another one over here on a circuit board. But maybe not. Anyway, it doesn't matter. So yeah, that's what this chip is. I'm assuming it is. It says it's a cell. What am I doing? I'm going there, aren't I? If I zoom in on this, this is the PCB design. To zoom in so close to be able to see it. Too close, I really can't get in there. Open image in a new tab. There we go. So yes, the PCB design that it comes up with is pretty blooming tiny. With the SIL module here, a couple of resistors and capacitors, and a diode. Minus 11.98 volts. Oh, I've got to have this one. I have got to use it. The footprint it's saying is 69 millimeters square. Nice. I have to use this one. There's no two ways about it. Although they are quite pricey little chips, these. Buying them direct from Texas Instruments, that's about $4 a piece, which for a voltage regulator chip is pretty blooming expensive. This is 23601. These are the 21701s. So these are the same family, they're just a slightly different version. So I might even be able to use these ones that I've already got. So yeah, they're tiny, they're really convenient, and they're expensive. But what you spend on these modules, you save on board space, you save on external components and you save on the complexity of your design. Because one thing that you need to do when creating a design for a switching power supply, you have to be very, very, very careful with the layout of your tracks, of the components, of your ground planes and things, to reduce the radiation, the electromagnetic radiation created by the switching and the oscillating of the actual device. So when you use a tiny little integrated device like this, it does all that for you. You don't need to worry about the layout. So yeah, for Texas Instruments, I tend to buy direct from Texas Instruments themselves. They tend to have better stocks, and they're cheaper than going elsewhere. So log in to view the inventory. And it's out of stock, of course. Isn't it always out of stock? Shipping, I think, is free. It comes by FedEx from either from America or from Germany. Got a big warehouse in Germany. We'll see what Mouser have. I usually use Mouser as my supplier. I find them the most reliable. Out of stock on Mouser as well. Right, so nice as that one is, it's not really practical because it doesn't exist at the moment. I can try DigiKey. Actually, if I take the R off the end, the R is a real 0 in stock. Zero in stock. 0 in stock. So no, I can't use that one, unfortunately. That's a nice design, but unfortunately not. It would be nice if they had on here the option to filter by in stock. Let's see what else it can come up with. I'm very, very much space constrained. I really want to either use just a single chip and a couple of capacitors for a charge pump setup, or an integrated module like this. That looks like it might be another integrated module, is it? Another simple switcher. They've got more components, but just resistors, so they can be small. Now, I'm not liking those designs, too complicated. CPC won't, but Farnell might. Farnell, they might have had it in stock at some point, but chances are they don't have it in stock anymore. No. Click off the R. Nope, they don't know what it is. Parnell's catalogue has been shrinking and shrinking and shrinking and shrinking. They just don't seem to have anything anymore. Try RS. Oh, I haven't used RS for a long time. No, they show me complete gibberish. Random devices that have nothing to do with anything. So I don't think they carry it. No. Right. I mean, there's nothing unique about this one, as far as I know. It's all to do with the arrangement of how you connect it that makes it the inverting variant. But it looks like the exact kind of layout of chip that I use for the existing 5-volt regulator. That's how it does its switching. P in, enable, P good, V out. So if I look at the actual schematic that it came up with, has it still got it? It was back to page 1 on this. If you take a look at the actual schematic, how does it... Yeah, here we go. This is how it makes it inverting. Quite probably. That's what I'm getting onto here. Because normally you'd connect V in and ground to 12 volts and ground, and V out and ground to your output. But instead, the way it's done here, you've got V in goes to positive, and V out goes to ground. And then ground becomes your negative voltage. So simply by connecting V out to ground, it turns an ordinary switcher into an inverter. So theoretically, any switching regulator can become an inverting regulator. Have a look. .5 to 15 volts. It gives me the 23601. If I restrict it to the right voltage range, it gives me one variant, and that is this one, or this one. So that's the only one they've got in the right voltage range. 23601. That's the only one they do currently, I think, in the 12-volt range, or 5 to 15-volt range. The one that I've had here, find it again. No idea what I've done with it now. Cubes of random chips. stuff like that. But the one I had there was the same family. In fact, this one on the board is the same family. It's just a different variant of. They do them different voltage ranges, different current ratings. And what was the one that I've got on the board at the moment? That is the 82130, TPS 82130. Which is, I suspect, probably discontinued now. No, that is in stock. That is good to know, because I use that one extensively. If I could do it with that one... I've just had chips, so I'm happy. If I could do it using that module... let's go for let's start a new design. I want to use that design, and they haven't got any designs for that chip. However, the chips are so similar. That I suspect it can also be used in an inverting arrangement. Typical application. It doesn't tell you that it can be used as an inverting one, but it might be able to. It's worth investigating, I suppose. Because the basic functionality is the same. Bring up you've got ground, V in, enable, power good, mode, feedback, V out. On this one, you've got V in, enable, that's SSTR, that's a bootstrap. V out, feedback, power good, ground. So the connections are basically the same, so it might be usable in inverting topology. It would be advantageous to use the same chip twice for it. One for the 5 volt, one for the minus 12. That is certainly worth thinking about. But I think I would have to experiment with it to know if it would work or not. So, do I assume that it will, design the circuit with it in an inverting arrangement and hope that it works? Or do I design an intermediate board, which is just this chip arranged in an inverter to just test, see if it will? I'm thinking I just go for it. Because if it doesn't work, I'll have to redesign anyway. And if I do a test one, then I'm going to be redesigning in the future regardless. So, yeah, Yes, I go for it with this chip, I think. The H2130. So let's make a let's start a new schematic. Don't have this component yet. Right. So V in. What have we got? I want enable. And SSTR, just call it SS, so I want to flip these over. I want over this side, I want the out. Oops. And I want feedback. And I want power good. I also require ground. Those over. Okay. Just pop some labels in here as well. Over. Them up neatly. Convert that into a component. And the device is the TPS 82130 SIL. Motor. Better save this component. TPS 82130 SIL. Okay, I've made the component. Want two of those. Be in on both of them enabled. Let's add a ground onto this one. So this one here is going to be the 5 volt. This one here is going to be the minus 12 volts. I need a capacitor on the bootstrap. Which one? Passive capacitors. Now I'm assuming for the inverting one that the bootstrap capacitor is just going to be going as per normal to ground. I'm hoping it does. V out will be going to ground. I need to connect up with 2 and 1. The power input. I need resistors for the feedback. Oh, wrong resistors. Oh, there we go, proper resistors. Resistors for the feedback networks. And 4 capacitors. 4 and after each one. Let's move that across. Find my voice therapeutic and soothing, do you? Oh, I'm glad I'm good for something anyway. Pull this down, aren't I? Let's get this selection direction right. Better. Things get a little more complex, don't they? That's the ground there. Isn't ground because it's actually V out. Down. Down to there. That's in between. Those go there. Okay. I have it there. One up. Keep it neat. Right. Theoretically, that might be it. That might be it. Apart from the pass through of the 12 volts, which is just that. Four pin connector. Now, I can't remember what the order of pins is on this. Right. Do you want me to take you through what is going on here? Just turn these around. Right. Orientation, so it's all neat. Right, what we've got is 12 volt input here on the left, which is split between being passed straight through at the top here and the inputs to two identical switching regulators. One of them is just with its ordinary arrangement with a feedback network that tells it what this voltage is, basically, and sets what the voltage is going to be. Feeds back in, so that knows how to regulate its voltage. So that'll be set to 5 volts. The upper one is my understanding of the other schematic is correct. Find it again, I'm not sure I've got it. It's basically running in inverting mode, where V out becomes ground and ground becomes V out, which then means that it's pushes the voltage down to below the V out instead of above ground, so you end up with a negative voltage. So hopefully, if I get the values of these resistors correct, we then end up with plus 5 volts there, minus 12 volts there, and plus 12 volts there. And that would then replace the entirety of the that would then replace the entirety of the Amiga's power brick. Have you ever seen the power brick on the Amiga? I don't have one. Let's just bring up a picture of the Amiga power supply. That's the original Amiga power supply. It's a chunky beast. I've got the image. No, oh, keep it. Half of these images are adverts. Google Images is getting really, really rubbish these days. It's all adverts, adverts, adverts. Trying to find one that's got some kind of size reference to it. There's sort of one, an original case with new internals in it, next to the Amiga. So standard size keyboard, so you can sort of see the size of it. It's a really big, heavy thing. They're also quite expensive to get now, so this tiny little circuit board replaces that and pretty much that entire big chunky unit. Oh, absolutely. Smaller is better with me. I like small. I like to take chunky big things and shrink them down. So all you need with this circuit board is a simple little wall wart. And this one is a EVE one, but my most common one I use are Netgear ones. Very handy Netgear ones. Got hundreds of those. So yeah, it just makes it so much easier and more convenient to power. Yeah, well, it's a similar thing with the VIC-20s and the Commodore 64s. They've had various different arrangements, but they had one where it had basically a big transformer inside it and a 5-volt power supply, and it gave out the AC direct from the transformer plus the regulated 5 volts. So the 5 volts would power the internal circuitry, and then the AC would then be fed through and back out the user port for powering the cassette and things like that. So that was a particularly complicated design to try and replicate externally with a third-party equipment. But this one at least is standard. You could replace this with an ATX power supply, because you've got the 5 volt, the 12 volt, and the minus 12 volts. But ATX power supplies are pretty chunky as well, so and you really don't need all that power. Most of the power that's used on the Amiga is 5 volts, which is why I chose the TPS 82130 originally, because it can provide 3 amps and is very efficient. So it just generates no heat at all, gives plenty of current to power all the custom chips, and it just works beautifully. It's only the negative 12 volts for the audio circuitry that's the sticking point, and I mean, this original chip that I used worked beautifully. It's just not a very friendly arrangement. So hopefully this arrangement will work better. But I can't remember what the pinout is. Oh no, what have you clipped? What have you gone and clipped? Oh no. Smaller is better with me. I like small. Thank you so much. Right. As I say, I can't remember what the pinout is on this, so I'm going to have to remind myself. What the pins are on this. I do have the original design here that I could possibly trace through, but easier just to buzz it through with the multimeter crunch. Right. Tell you what. Let's see if I can do something with this. If I bring this mixer up. I want on stereo 1 and 2. 1 and 2. I just want to turn this down a bit. There we go. And yeah, that's working. Now, hopefully, you should be able to hear me beep. Right, let's put the right glasses on. And if I find any ground connection, there's a ground connection. Okay, this end here is ground. So I shall nominate that as pin 1 on here, I think, initially. Now, You hear me? Oh, of course you'll hear me twice, won't you? I mean, I could mute that one, and then you'll only hear me on the ASMR microphone. It's through having two microphones turned on at once. If I find any standard 74 logic series there, for example, that will be 5 volts. So second pin there is 5 volts. So I shall connect the 5 volts up on that one. So next, 12 volts. Now the easiest way is which one goes straight through from the middle pin. The far end is plus 12 volts. So I connect that one up, which then means if I go from there to TL084, if I remember rightly, that should be, no, which one? One of these has got minus 12 volts as a standard pinout, I think. Those are all logic. TL084, I thought that was a dual op amp, or even a quad. TL084. Ah, no, it's that side. I was right, but on the wrong side. There it is. Yeah, so that is minus 12 volts. That all checks out. And change back to my other glasses so I can read you. And then switch back to my proper microphone again. Right, I now know which pin is which. I have connected them up on here. So you've got ground, you've got 5 volts, you've got 12 volts, you've got minus 12 volts. I don't use the power good outputs on these at all, they're pointless. Now it's a case of calculating the resistors. I bring up the data sheet over here. No shortcut to get to where it says about calculating the resistors. Setting the output voltage. The output voltage is set by an external resistor divider according to equation 6. V out equals VFB times 1 plus R1 over R2, which equals 0.8 volts times 1 plus R1 over R2. R2 must not be higher than 100 kilo ohms to achieve high efficiency at light load, while providing acceptable noise sensitivity. Okay, so figure 8.1 shows an example for 1.8 volt. So we've got 124 and 100 for that. So normally you would choose one standard resistor on one side and then vary the other one to suit. This doesn't give any other examples other than that one. So I'm going to choose 100 for the R2. And so we have 0.8 times 1 plus some value oh, good guess. 4.8 volts. I need slightly more than 500k there then. 520, 4.96. 520k I think is a pretty standard value, isn't it? 520. Let me just check. Passive components, resistors. SMD. No, there's no 520 in the list at Mouser. 530? What would 530 give us? 5.04. I'm happy with 5.04. That's within specifications. Um, 530 doesn't give us many options of providers though. $523 gives quite a few. 523 looks a good value. 4.984, that's good. Okay. 523 kilo ohms should do the job nicely here. On this one here. And on this one, 100k. Now, which way round does it go on here? Because the output is inverted, but still referenced to ground at this point for the feedback. Was it referenced to V out? No, it's got to be referenced from ground because it's still got to be a positive voltage for the feedback. Only after this that it becomes inverted. So yeah, I think the lower one here is still 100k. But if I want 12 volts, which will get flipped over to minus 12 volts, what happens if I use... That was around 5 volts for... Oh, 500 for 5 volts. So if I go for 1200? 1500, 12.8. 1400, right. Actually, if I drop that to 10, I can use 140. That should give me exactly 12 volts. So if I put that to 10k, is there such a thing as a 140 commonly available? Yes, 140 is widely available. That's good. I think those values might give me the right voltages. If I'm lucky. Value in. 10 microfarad for the inputs, 220 for the soft starts, 10 for the outputs as well. That might be it. I'll be selecting parts for all the passives and things right at the end, because these are jelly bean parts. There's thousands of different manufacturers and different part numbers and things that will all do the same job. Those things like the capacitors and the resistors, they're irrelevant. It's only the 2 chips and the socket which I normally use. What is it that I normally use? It's called an... I think that's the one. No, that's not the one. That's the through-hole version. Can't remember which socket I used for this. It's a fully surface mount one. It's the same socket as I used in my EFT screen one, isn't it? I did this in Leapt. Have I updated this? I don't think I have, so if lepton even still works. That is that part number there. No wonder I couldn't remember what it was. It's 694 106 106 102. Which is on Mouser, yeah. Although it looks different on Mouser. I think that's just a stock photo, but on Parnell there. That's the one that I use. Now wrong with tangents, but it's the cryptically named 694.106.106.102. That's the connector I need, which is available on Mouser. As I say, it looks they've got a different reference image there for it, but it's the same thing. Earth Electronic from Germany, in stock. So, device is that. Actually, I shall set the device. Set the device to be a floater. I've got it there as a reference. Right. So what I do need to do is set footprints for all these. I shall set this footprint to be the same as the device. Same with these, I think. I'm going to have to make footprints for these. This one here, I'm going to have to create a footprint for, but I'm going to do that in a special way. This one here, 12 volt. I'm going to want 1206, aren't I think? One here, I'll use 0603. And resistors. Now, do I want to go 0603 or do I want to go smaller? I'll go 0603 for now. I can use 0402, but that's just a bit too fiddly. Is it worth it? Oh yes, they're very, very well made components. Components are. They are definitely worth it. 0603 for that one. B and 0603. Now, I'm going to create a procedural footprint for this one. So if I just go over to another fresh screen, bring up PCB R&D, I can create a procedural connector to be down here. I need a connector which has 1 on the X, 4 on the Y, and I need, I think it's a 200 mil spacing. I need a 1mm drill, and I want a ring diameter of 1.4mm, I think. Should do the job. No, I'll go 1.6. That, I think, it. I'm gonna make the hole slightly bigger, 1.2, with a 2mm annular on it. That's good. Right, so now that gives me down here this long string, which I can come back over here and put in to the footprint. Right, so that should now automatically generate that footprint for me when I import the schematics into PCB R&D. Which I'm going to do now. Let's make sure I save that. Back to here, file, import schematics. Here in the PSU. Hello, what are you doing? Seems to have frozen in some way. Something's not happy that. No. All -9 PCB. Let's kill it. Let's do it properly. Start it from a shell. Okay, and bit so we can see everything. Let's import schematics. One more, browse. There's the schematic import. And we've got, I forgot one whole section. One whole step I forgot. Let's not import the schematics yet. Let's go. Can't ever remember where it is on here. Change multiple objects, renumber symbols. Renumber all the symbols. There, they've all got proper FDES. C2, C4, U2, U1. Instead of just all being called C question mark, R question mark, con question mark. So I'll save that again. Come back over here. Now I'll do the import. And now it complains that netlist failed to produce a reusable output. Okay. Save. Import. Messed this up, doesn't it? Let's clean this up. Oops, there we go. It got the path wrong. Right, that's imported everything except. Fair enough, Cobb. I'll see you next time, hopefully. Have a good rest of the evening. This has imported everything except the chips. Because I don't have the right footprint on those, and I need to find my old footprint. footprint and see what it's named. TPS 82130 SALT. It's got the T suffix on it. That's why. I give it the T suffix on here. T for cut tape rather than R for a reel of them. No way I can afford a reel of these. Use this one as well. Give it the T. Save it. Switch back to here and import. There's the chips. And lock floaters so that I can move things around more easily. Oh, and of course I haven't mapped the pins, have I? Another stage I need to do yet. And that is to create a port map, I think. Yep. Where I map the pins of the component to the physical pins on the footprint. So if I zoom in on here and terminal names, I've got pin 1, 2, 3, 4, 5, 6, 7, 8 and EP. So if I get the data sheet of this, get the pin out, move that over to the other screen for the moment. You won't be able to see it, but I can see that and this at the same time. Right. So on the symbol, I've got the pin name of VIN, which is on pin number 1. No, it's not. That was on pin number 2. I have EN on here, which is on pin number 1. I have SS soft start on here, which is on pin number 8. I have B out is on pin number 4. I have feedback is on pin number 6. I have power good is on pin number 7. And I have GND is on pin 3 and also the exposed pad. Oh, actually, V out is also on pin 5. I was getting confused here because there's 8 pins on the chip, but I've only got 7 on here. I couldn't work out which pin was missing. And it's because there's 2 pins for V out on both 4 and 5. And why that's saying I've got that on 6 and 7. Be on 6. I should be on 7. V out is on 3 and 5. 4 and 5. Ground is on 3 and EP. That should be it. I'm going to just remove that from there and place that one in its place. Change it to U2. That should now, if I re-import and update the rat's nest, there we go, all my connections are there. Now, this has the wrong connections though. I've got two connections going to opposite pins rather than adjacent pins. So I got here pin number wise. Put it down into the board so I can zoom in better. 1, that's 2. That's saying 1, that's saying 3, is it? On. How does this work? Yes, there's 3 pins. It is confusing because they're not properly laid out. You would expect. Back over here. Yeah, a bit of background music would be nice. I've still got that open. Yeah, let's if I were to turn this down and pick something at random. Cubic Z. A little bit of background music. Yes, the pinout on this is a little strange. You've got 1, 1, 2, 3. 1 is the pin. It's going to be 12 volts. 3 is the switched output. 2 is the copper output. So actually that might be correct. So pin 1 I need to have as 12 volts. So these are backwards, that is right, yeah. So if I flip that over, resave it, come back to here, re-import and relay out. So this one here, pin 1, should be all my 12 volts. Yes. That's good. That's the right way around now. Okay. So now we just need to lay everything out and connect everything up. So U1 is the inverting side, along with C1 and C3, C5. 5, C3. That's 1. Then the 2 resistors are R1 and R2. R1 and R2. around there. That into there. In a little more. Packed it in as much as I can. That might be it for that. One up. Come in here. Lines with the middle there, doesn't it? Yes. D4 comes down underneath here. This is the top, not the bottom. No idea what we're listening to now. This is called Cuckoo's Nest, apparently. It's by Nat Keefe and Hot Buttered Rum. Cross one there. Back into here. It's a pretty good tight layout there. I'm not going to need internal layers for this. Let's remove them, not duplicate. Okay, so set my standard sizes here of 0.15 millimeters with a 0.15 millimeter clearance. Hit my hit 0.3 millimeter drills. I want 0.6 millimeters on the copper. I think that's it. Oh, what's the clearance? I don't think I set that here, do I? No. Use selected. Okay, so this is my small signal layout one. I might use my power layout for this, which is 0.3 millimeters with a 0.15 millimeter clearance. Still using the same fire from before. Yes, that's a better one for here. And this one is called Dancing on Green Grass. Apparently it's in the children's genre, so I think we'll just skip over that rubbish. Disco Nights by Quincas Moreira. M-O-R-E... Is that an I-R-A? Moreira? Who knows? Right. that's those simple bits connected up. Now the fun begins. This is the ground connection, which is actually the V out connection. So let's this just to here and down here and back up. Good connectivity around the that. All the way across to that. This is going to all be filled up. I do annually. It can be a bit tedious, but I find it's the simplest way of doing these big, chunky power connections. Could be done with a polygon, but they get awkward to manage. Yep. Except, hang on, this. No, that is right. That's all ground. Ground is ground is ground. Even though it's on V out, it's ground. Yeah, I was getting confused then. Right, V in on here. Similar idea. We're going to take a big chunky power connection arrangement made up of lots of lines. Good. Then we have the actual ground, which here is the V out, which gets slightly more complicated now. Hoping we can just connect straight across to there. I need to get this out from the inside. I don't really want to go through there. So actually I might rotate this round possibly. Or do I just go underneath? We're fully wired up here, so I think I'll go underneath on this one. Go big chunky connection to here. next up, Erev Shel Shoshanim by Ease Jammy Jams. Sounds like what he goes to bed in, isn't it? Have you got your jammy jams on? I'll bring this out this way a bit here. Well, yeah, the problem is I'm just playing in the web browser at the moment on the YouTube audio library. And there's no way I can get at that information to have it display. That would require using some kind of API or something, isn't it? I'm going to stick a couple of wires there. I'm going to stick a wire there. I'm going to stick a wire there. Back onto the top layer. Nice chunky connection this way, up here, around here, back up to here. Then maybe I should just download the whole of the YouTube audio library. And I could stick it all into Clementine or something. That's looking good. Now I've got to get that down to here somehow, but then that also goes up to there. That's just going to ground, isn't it? So I'll just stick a wire in there. Because on the underside, I'm just going to put a great big ground plane. I might spend a couple of productive hours at some point downloading a load of the YouTube audio library and sticking it into Clementine, and so it'll just sort of play in the background and pop up messages in the corner. I'll have to take a vote beforehand, though, on what genres people want me to download. I'll only download what people want, of course. Right, these are... yeah, these are sort of round the wrong way, I think. I want that up there. I want... all of this up here. That's a bit better. A bit more sensible. Right. Let's just quickly lay out the internal bits of this. Want connect the ground up there. I'll connect this ground up here as well. The good chunky. I want to bring that into there. Up to here, a bit more there. That's looking good. Add up. That can come out of here. Here. So, not a bit. Good. That goes to ground. Right. Output here. Let's make this nice and fat. I like good fat power traces. It comes to switch mode power supplies. Keep the impedance as low as we can. That's done. All that's left for here now is the input. Which I shall just put like this to here. Now we are listening to Fiesta Jaroja by Jimena Contreras. I think I got that right. Bit that. That's looking pretty good. Might just put these bits up in here in the feedback network. The impedance of that as low as I can. Right. All that's left now is ground connections and laying it out in the proper board shape. Now, remember what the no way I can remember what the dimensions of the board are. No, this is the Ring Dove suite, which I do tutorials for on YouTube. It's all created by a lovely chap who goes by the name of Igor2 from Hungary, and it's a fork of the GEDA GEDA no media suite, which has pretty much died a death. And he's taken that and he's completely rewritten it, and it's a brilliant system. It's very old school, but it is a very good system. He's got some fantastic facilities in it, and he's forever improving it all the time. And it's got a very fast development cycle on it, and is an incredibly good programmer. Very diligent and creates very good software, very clean code that does wonderful things. And I just love using this program. Right, this is has a dead battery in it, which fortunately hasn't leaked. I haven't used these properly for a long time, and this is an A76 battery in my calipers. I need to get a battery. I think I've got one in here somewhere. I think those are the ones. A76, yes. Although they've been in the packet here so long now, they've probably all gone flat anyway. Is this going to work? Not that the calipers themselves work though. These are the most useless calipers ever. Oh. We just had Fiesta de la Vida by Aaron Kenny, and now we are on Fine Line by Geographer. Right. Let's see. I want millimeters. I'll show you why these are the most useless calipers ever. Now they're all exactly the same. The chemistry is the same this side of the pond as it is yours. If I open these up, slowly. Oh, yeah, a few little blips then. Oh, look, suddenly I'm on -2 millimeters. They are the worst calipers ever. Goes back up. Oh, I'm at -15 millimeters. Yeah, they are the most. I call them my quantum calipers. I change the outcome by making the measurement. So they are completely useless for that sort of thing. But they're okay for just estimations. So the length of that is, I'd say 33. 33 millimeters long. Let's switch over to absolutely. I quite fancy a good pair of purely analog ones that don't require a battery. Right, so back over to here. If I switch into millimeter grid now, do 1 millimeter spacing. I shall go to top assembly, no, outline rather. start off with a line there. So 33 millimeters is that big. So that's how much room I have to play with depth-wise. The top section, or what I call the top, the power input connector side of it is, I'd say 22. Oh, by the way, we're now on First Class by DJ Williams. Well, the calipers think it's 22 as well. Let's go for 22. We have consensus. 22. So we want this. Doesn't really matter that much where. Switch back over here. I'm going to choose here, I think. That's the top of my front section. So 22 is there. Let's pull this up to 22. Now we're on Fly Away by Otis McDonald. Okay, now I need this length here, which is that's about 19.2 millimeters apparently. I'll call it 19 millimeters. So if I come get on the right layer, along here 19 millimeters. Then the depth of here is looking like 34 millimeters, the depth there. I don't think so. I think we're near 3 millimeters. I think I saw 3 millimeters briefly then. Compute that. So I want 1, 2, 3. There we go. And that comes right down to here. Now the other side. That. This here is about 10 millimeters, and the calipers agree. Millimeters, and coming out another 3 there. It's the same size as the other side. 1, 2, 3. 1, 2, 3. Now we have Freylac 1. He's jammy jams again. He's in his jammy jams again. Now it gets a little more interesting here. I'm thinking, eyeballing this, I'm thinking I've got 333. I'm thinking, because we've got this curved bit here, or semi-curved bit, angular bit, I'm thinking I've got 3mm, 3mm, and 3mm there. Or have I? That could be nearer 4mm actually. I'm thinking I've got 4, 4, 3 actually there. 4 there, 4 there, and 3 there. So if I come in 4 here, 1, 2, 3, 4. And then 1, 2, 4, 1, 2, 3, 4 there. That's my 4 length. That, and now I'd go 1, 2, here I'd go up 1, 2, 3. That comes up to there. That goes to there. That goes across to there. I delete those. And bring that down to there. You can now see the actual size of the board that I've got to play with. So I'm going to move these right out of the way for the moment. I'll not select. Turn the outline off. Move those way out of the way. Okay, now turn the outline back on. This has to go here. That has to go there, although actually I could... At the moment I've got it flush with the board, I'm thinking I might move it forwards actually, rather than having it flush with the edge of the board, but overhanging slightly. For that side. These might just squeeze in here. Here we go. We're now on Fralac 2 by these Jammy Jams. There's lots of these Jammy Jams coming up. I thought we might be having a bit of a samba party soon. Okay, what have we got here? This is ground. I can ignore ground for the time being. Let's take power input. Make a fat. Makes 2mm. there. Not into there. I need to get this to here. Start off by bringing it up here. And down here. Are you not enjoying this? Oh, we'll have some Freeling by Lauren Dusky then. It was going on a bit, that one, wasn't it? So we'll rule out Ease Jammy Jams from the big download then. I shall bring this just up into here between the two. Flatten this up a bit down this way. Here. And we'll switch to power. Inner traces in here, I think. That's looking quite good. Now we've got more Lauren Dusky, and this is 3 days. Right, it's actually a much smaller circuit than the original one, obviously because the I haven't got the huge chunky chip in the middle of it all. What I'm going to do on this one, I'm going to bring this through as well to this side, just to keep the impedance low. Now I just need ground, but first we can shrink the board. We don't need all this space anymore. Hang on. Why didn't you tell me you can't see anything? Here's me working away. I've got the wrong blooming scene showing, haven't I? Ugh. I need a telephone. Call me. I can shrink this down now to be more like this. Go. Much smaller board. And now let's put in some ground. Which I will use a polygon. So if I'd stopped talking, you'd have got completely confused, would you? I need to move this slightly. Not in a good position. Right. Right, and then I want the top ground to do the same. Okay, now connect up these. One of the failings of PCB R&D is its SMD pad thermal system, which is inherited from the original PCB. If I turn on thermals on here, turn off this, you can see, you get very small thermal fingers, which are not good, and there's no way of changing them. Down here, they're tiny little thin things. So I draw all my thermals by hand. I'll use a thermal, but I shall, from it, I shall use a solid connection thermal, I think. Or will I? No, I shouldn't. A pain having them like that. I won't do that. I will draw it manually. Bottom. Right. Almost there. Want some wires here. Just give me grid alignment now. So fire there, fire there, fire there. There, there, and there. I want good ground connectivity here, you see. So I shall use thermals with a solid connection. That one. What are we here? This is... that's ground, isn't it? That's V out, which is ground. So actually, I don't want this big pad here, do I? This big chunky trace. That. Move all of this rubbish from around here. Oh, I've just noticed we're back onto Ease Jammy Jams again. And it's in jazz and blues mode at the moment. So here, instead, what we want is some thermals to the ground plane. In fact, for some reason, we're listening to Happy Birthday in various different styles. I'm going to fast forward. I'll have that one. We don't want to listen to 8 different versions of Happy Birthday, do we? This is supposedly pop. I think it's more polka than pop. Skip that one. Right. That's looking all right to me, I think. Tidy up all the text now. To only floaters mode. I think we might have completed it. I'm just going to add future reference. What's what? Plus 12 volts goes there. And go there. 5 volts goes there. Minus 12 volts goes there. I think that might be done. No, I use Elecro. They're pretty damn cheap and they're fast and they're good, and I've built up quite a good relationship with them. I have been offered a sponsorship deal with PCB Way. Oh, I don't like that there. That's a bit close. But I haven't taken them up on that offer yet. Corner up. Let's see what we can come up with on this then. I make it look easy because of years of practice. Right. Editor, open. $500 PSU. And PSU. Run. Run. There we go. The bottom never does it properly, does it? Not that much on the bottom to see, but yeah. That's roughly how it would come out. Let's remove the sun. Myself a what is there? And I want maybe it's background environment texture. That's what I want. HDR. Pick a random HDR map. Load. Transparent. That looks much better. Oh, is this Bloominese Jammy Jams has snuck in again? Go away. Okay, to the 3D viewport. Zoom this in a bit closer. Down, not too far. Like this. And render. Had all my models all sorted out for all the components. It would actually show all the components and everything on there, but I haven't got any of them sorted out for my new setup yet. But that's looking good. I think I'm ready to order that. Yeah, that looks good to me. Hopefully by next stream I'll have had my email. Because it takes a couple of days to come through. My emails, just to check nothing's come through. No. It says on There we go. And it's heading towards 10 o'clock, so I've done one of my boards. Only another 3 to go. But that's a pretty good achievement for one day, I think. One of the great things I've found with streaming is all these jobs, all these things that I've been meaning to get around to doing and just never found the time or the energy. It gives me an excuse to do them. So these are things that I've been wanting to do for a long time, but just never really had the impetus to do it. So by streaming it, it gives me a slot where I can sit down and do these things that I've been wanting to do for a while now. So have a nice close-up of me. Double Matt. Let's have double Matt. Double Matt. Way. Oh, yes. So yeah, that was a good. I get to put up with you. What do you mean put up with you? You're the whole reason I stream is to hang out with you guys. Right, I need to make sure this is. I don't want that music anymore because I'm going to start the outro now. That reminds me, I just need to make sure that nobody has subscribed on Patreon, and if you haven't subscribed on Patreon, why not? Come on, get on to Patreon. Let me just update my member list. Oh, hang on. That's not good. I'm glad I checked that. I've got debugging stuff in my my output at the moment, so it just filled my member list with all sorts of junk. Then, glad that wasn't streaming out. Did that print? And run that again. Oh look, nobody else has subscribed. You're still all alone there, Carrot House, you poor thing. You have to encourage some people to sign up, aren't you? Come on, do your job. Come on. Right, let's get the outro going then. I need to turn that down. I must turn that off from the monitor because I don't need to listen to it. It just echoes around if I do. Right, well, thank you so much for joining me today on this bit of a PCB designing extravaganza and general chat and a bit of fun background music from courtesy of YouTube. So yes, if you enjoyed this stream, you might want to follow and get my count way up. The next waypoint on this is 200 followers, by the way. So you might want to follow to be notified when I stream next, which is on Thursday evening, 7 o'clock GMT. I might be doing some more PCB work then. You might be lucky. I'm not sure what I'll be doing then, actually. Patreon, of course, you get your name down here, you get early access, you get to join in the fun that is Patreon, the community we're trying to build up over there. And I'm on YouTube, of course, you'll find my videos over there. These VODs end up being dumped over on YouTube as well if you want to watch them over there. And Discord, of course, you'll find me over there somewhere. So, and the Carrot House bot is running nicely, thank you. So yes, well, thank you very much for joining me. I hope you enjoyed it and maybe learned a few things along the way. Probably not. But yes, see you on Thursday and cheerio.